I'm now going to have a look at how you can create surfaces directly onto the scan data. And I'm going to start with the square tool here. The square is normally used with 4 boundary curves, but it can also be used from 4 corner points. So I'm going to curve snap onto this mesh, and I'll just do this windscreen area here. And I need to trace around the 4 corner points, either in a clockwise or an anti-clockwise direction. And that creates a flat 4-sided surface between those points on the mesh. Now clearly it doesn't yet fit to the mesh, but now I can use another tool on Surface Edit which is called Fit Scan. And for this I need to pick both the surface and the mesh together, and then click on the Fit Scan tool. But in this case I've got an error message because I've transformed my mesh into this position. So it needs me to do a 0 transforms first. So if I select the mesh and then do 0 transforms, it doesn't look like anything's happened. But now if I pick those two again and do the fit scan, then this time it works. And if I open up the option window for fit scan, then it's keeping the original surface here and creating a new one. And up here it's giving me the degree and the spans, so I can change these here if I want to, and just apply that. But I'm just going to keep it at degree 3 in both directions for now. I can show the deviations between the scan and my NURB surface, and it's showing around about 4 millimeters, which isn't too bad at this stage. And the projection direction defaults to the surface normal, which works fine here, but I can change it if a particular direction suits it better. So that's got me started. And I'll just take my original surface here and template it in case I need it later. And now we need some information on how well we're matching the mesh. So I'll apply some X direction cross sections. And then if I toggle the model off, you can see the green lines are my new surface and the brown ones are the mesh. So it's not perfect yet, but it's reasonably close. So now I can work on getting the boundaries closer to the windscreen outline. And I'm going to use the Transform CV tool, and I'll just use the slide option with Pick Hull to start with, because that will keep my CVs in a disciplined layout as I move them. So slide allows me to adjust the CVs by moving them along the hull lines. And so I'll just pick this hull and move that one down as well. And to go on to the next hull, I can also use the Pick Walk, which is the control key with the arrow keys. And that lets you move along in the U or the V directions. And I normally just experiment with the arrows to find the right direction. And if I want to make it longer on one edge, then I can use the Object Edit Extend tool and just lengthen or shorten it without changing the shape. And these blue arrows are useful because it allows me to slightly twist the edge and bring one end further out than the other. And if I want the surface to extend just where there's one CV, then I can use the slide tool again, but just on a single CV. And so I can adjust the surface to where I think the boundaries need to be. So the sections are still looking fairly close, but I want to sort out the center line accurately before I go any further. So I'll create a new layer and put the surface onto it, and then display the symmetry. Now I need the surface to be smooth across the center line, and at the moment it's not even lying accurately on the center line. So this is where I'd use the Symmetry Plane Align tool, which works on the layer symmetry direction. So if I click on this edge, it snaps the first row of CVs to the center line and aligns the second row so that they're tangent. So if I apply the zebra stripes to check what's happening across the center line, it shows that the tangency is fine, which is a good start. But I really need more information to refine it to G2 or G3 quality. So I'll use the cross-section editor and put the curvature cone plot onto the sections, and then double-click to get the controls so that I can scale up the cone plot. And now I can see that I've got a lot more work to do. And I'll keep working with the CVs, and if I use slide, then I can use these double arrows here to explore how changing the angle of the hull will help the cone plots, while keeping the tangency across the center line. So I've gone about as far as I can go modelling by eye. So in the next tutorial I'll look at measuring the deviation accurately.